In fluid dynamics, the Stokes stream function is used to describe the streamlines and flow velocity in a three-dimensional incompressible flow with axisymmetry. A surface with a constant value of the Stokes stream function encloses a stream tube everywhere tangential to the flow velocity vectors. Further, the volume flux within this stream tube is constant, and all the streamlines of the flow are located on this surface. The velocity field associated with the Stokes stream function is solenoidal. It has zero divergence. This stream function is named in honor of George Gabriel Stokes. Cylindrical coordinates. Consider a cylindrical coordinate system, with the z-axis the line around which the incompressible flow is axisymmetrical, phi the azimuthal angle and rho the distance to the z-axis. Then the flow velocity components u-rho and uz can be expressed in terms of the Stokes stream function by the azimuthal velocity component u-phi does not depend on the stream function. Due to the axisymmetry, all three velocity components only depend on rho and z and not on the azimuth phi. The volume flux through the surface bounded by a constant value psi of the Stokes stream function is equal to 2 pi psi. Spherical coordinates. In spherical coordinates, r is the radial distance from the origin, theta is the zenith angle and phi is the azimuthal angle. In axisymmetric flow, with theta equals 0 the rotational symmetry axis, the quantities describing the flow are again independent of the azimuth phi. The flow velocity components r and u theta are related to the Stokes stream function through. Again, the azimuthal velocity component u phi is not a function of the Stokes stream function psi. The volume flux through a stream tube, bounded by a surface of constant psi, equals 2 pi psi, as before. Vorticity. The vorticity is defined as where with the unit vector in the direction. As a result, from the calculation the vorticity vector is found to be equal to comparison with cylindrical. The cylindrical and spherical coordinate systems are related through an alternative definition with opposite sign, as explained in the general stream function article. Definitions using an opposite sign convention for the relationship between the Stokes stream function and flow velocity are also in use. Zero divergence. In cylindrical coordinates, the divergence of the velocity field u becomes, as expected for an incompressible flow, and in spherical coordinates, streamlines as curves of constant stream function. From calculus it is known that the gradient vector is normal to the curve. If it is shown that everywhere using the formula for in terms of, then this proves that level curves of a streamlines. Cylindrical coordinates. In cylindrical coordinates,